Welcome to this video on how convolutional neural networks detect edges in images. This is a foundational concept that helps us understand how deep learning models can recognize patterns in visual data. Before we dive into convolutional layers, let's understand what an image actually is from a computer's perspective. An image is simply a grid of pixels, where each pixel has a numerical value representing its brightness. For simplicity, we'll work with grayscale images where each pixel is a single number between 0 and 255, with 0 representing black and 255 representing white. Now, what exactly is an edge in an image? An edge is a boundary where there's a significant change in pixel intensity. For example, if we have bright pixels next to dark pixels, that transition forms an edge. Edges are fundamental features that help define the shapes and objects in an image. They can be horizontal, vertical, or diagonal. Now, let's explore how convolutional layers can detect these edges. The key component is something called a kernel or filter. A kernel is a small matrix of numbers that slides over our image, performing a mathematical operation called convolution. For edge detection, we use special kernels designed to highlight areas where pixel values change rapidly. Let's visualize how convolution works for edge detection. Imagine we have this simple image with a clear vertical edge. We slide our vertical edge detection kernel over the image, positioning it at different locations. At each position, we perform element-wise multiplication between kernel values and the corresponding pixel values, then sum up all the results. When our kernel is positioned across an area with no edge, the positive and negative values tend to cancel out, resulting in an output close to 0. But when the kernel aligns with a vertical edge, with light pixels on one side and dark pixels on the other, we get a strong positive or negative response. Different kernels can detect different types of edges and features. For example, this kernel detects horizontal edges. This one detects diagonal edges. And there are many more kernels for detecting various features like corners, blobs, and textures. In a convolutional neural network, the amazing thing is that these kernels aren't manually designed, they're learned during training. Early layers usually learn to detect simple features like edges, while deeper layers combine these to recognize more complex patterns like textures, parts of objects, and eventually entire objects. The output of each convolution operation is typically passed through an activation function, like ReLU, which introduces nonlinearity and allows the network to learn more complex relationships. To summarize, convolutional layers detect edges in images by using kernels that slide over the input data, performing mathematical operations that highlight areas of significant pixel changes. This edge detection is a foundational building block of computer vision systems, allowing neural networks to recognize increasingly complex features and eventually entire objects. Whether it's identifying a cat in a photo, recognizing faces in security systems, or helping autonomous vehicles understand their surroundings, edge detection is where the visual understanding begins. Thank you for watching.